Class number 1, Daily Summary. In this lesson, we introduce the mathematics of voting by exploring the plurality method and the Borda method. Demo number 1. Our first major topic of the year is voting. We introduce the mathematics of voting with a tasty example. Rank the following flavors of ice cream: strawberry, vanilla, chocolate. Go ahead and fill yours in. I think vanilla and strawberry are really good. I have chocolate at a distant third. Number 2, when you ranked the flavors of ice cream, you created a preference ballot. That's a single person's vote. Now we tally everyone's preference ballot in this preference schedule. So show of hands if you, so go ahead and find your column here, but we're gonna start going left to right. So the first column would be the people who thought chocolate was the best, vanilla was second best, and strawberry was third best. So show of hands if you are in that column. All right, I see 5 hands here. Next column, chocolate first, strawberry second, vanilla third. I count 7 hands. Next column, vanilla, then chocolate, then strawberry. That's 8 people. Next column, vanilla, strawberry, and chocolate. I see no hands going up, so I'm going to count my ballot only. Strawberry, then chocolate, vanilla. I don't see any hands there. And then finally, strawberry, vanilla, and chocolate. I count 3 hands. So this whole thing is called a preference schedule, and it is a collection of everybody's preference ballots, and it's a very concise, compact way to collect everybody's preferences. Typically, you would not even bother including a column with a 0, so after the fact, maybe we would erase that column there or not write it in the first place. Okay, number 3. Now our job is to determine which of the flavors wins according to our class vote. The first method is called the plurality method, where the winner is the candidate with the most first place votes. This candidate is called the plurality candidate. Let's count how many first place votes each flavor got. Okay, so looking for first place votes only. So that is going to be in this first row. And we can see chocolate appears twice, but you can't just say that chocolate got 2 votes because this first chocolate represents 5 people thinking chocolate was best. And the second one represents 7 people. So altogether, chocolate got 12 first place votes. Looking for vanilla, that's these 2 columns right here. So we see 8 people plus 1 more person, that makes 9. And then finally, strawberry first. We had nobody in this 5th column and 3 people in the last column. So that's 3 people altogether who thought strawberry was the best. Number 5, who is our winner by using the plurality method? So the winner is whoever has the most first place votes. So chocolate, 12 votes, wins our class vote. 6, let's list the complete ranking of the candidates according to the plurality method. So complete ranking means we don't just put first place down, but we also rank second and third and more if there are more. So clearly, chocolate wins with 12 votes. And then second place, well, we got to choose the second highest number, right? So between strawberry and vanilla, vanilla has more, they have 9. And then finally, third place is strawberry with 3. And so that means that our ranking is chocolate first, vanilla second, strawberry third. 7, if one candidate gets more than half of the first place votes, then that candidate is called the majority candidate. So more than half makes them the majority candidate. Did we have a majority candidate with our ice cream example? Well, to know whether or not we had more than half, first we need to know how much half is, which means we need to calculate how many people participated in this election. So let's first get our total. So the total number of people, well, we had 3 and 9 and 12, so just add those up. 3 plus 9 plus 12 gives 24 voters. And actually, there's a way to get that number just from the preference schedule, even if we haven't calculated the plurality method yet. And so coming up here, I could have done it right here by calculating the sum. 5 plus 7 plus 8 plus 1 plus 0 plus 3. We should not be surprised to get 24 there as well. Okay, so 24 voters altogether. And remember, a majority candidate is somebody with more than half. So if we had 24 voters, that means that half is 12. Did we have somebody with more than 12? We need more than 12 to be a majority candidate. So in this case, chocolate had 12, which is not more than 12. So the answer is no, we did not have a majority candidate. We needed somebody to have more than 12 votes. So that's the answer to part B. How many votes are required to have a majority in this class? Greater than or equal to 13. 12 does not cut it. C, how many votes are required to have a majority in a class with 50 students? So 50 students, half would be 25. We need more than half, that's 26. 17 students, half of that is 8.5. We need more than half, that's 9. So there's a slight difference in the calculation when you do even and odd. Okay, next page. We'll now look at a completely different method for determining the winner of an election. It's called the Borda count method. It's used in the AP College Football Poll to rank the top 25 teams in the country, where each candidate receives points for each vote they receive. We will give a candidate 1 point for a last place vote, 2 points for a next to last place vote, and so forth. For example, with 4 candidates, a 4th place vote, that's last, is worth 1 point, a 3rd place vote is worth 2 points, a 2nd place vote is worth 3 points, and a 1st place vote is worth 4 points. So my way of thinking about this, I mean, I guess you could just start with the 4 candidates and say, okay, the 1st place votes get 4 points, 4 candidates, 4 points, but I much prefer starting at the last place position because I know always last place is worth 1 point, and then I can just count my way up, 2 and 3 and 4. If instead we had 11 candidates, then a 1st place vote would be worth 11 points. But like I said, I always start with last place and give them 1 and then count up from there. Number 9, here's a preference schedule for electing the president of the math club. The candidates are Alicia, Boris, Carmen, and Dave, which we will abbreviate A, B, C, and D respectively. Okay, so here's our preference schedule. 14 people thought that the best ranking was A, then B, then C, then D. 10 people thought the best ranking was C, then B, then D, then A, etc. And so we're going to use the Borda count method to determine the winner of this election. So let's give this a shot. Remember, 1st place, well, we'll start at the last place votes. Last place votes are worth 1 point each. And so if we're going to give 1 point for everything you see in this bottom row here, then just focusing our attention right now on D in this first column, D gets 1 point for every person that ranked D in 4th place. And in this case, there are 14 people that ranked D in 4th place. So 14 people each gave D 1 point. That's 14 points for D right there in that column. We're moving on here, just continuing in the bottom row. 1 point from each of 10 people. So that's 10 points there. 8 people thought A was the worst choice here. 4 people. And then finally 1 person, 1 point. Okay, things get a little bit more interesting when we move up a row. So 2 points for any 3rd place choice. Okay, so let's focus our attention right there. So 14 people thought that C was the 3rd best candidate, which means 14 people thought C was worthy of getting 2 points. So what do we do to calculate how many points C just earned? Well, we should be multiplying, right? 14 people each gave C 2 points. So 14 times 2 is 28, and that's the number we're going to put right there next to C. Okay, moving on to D right here. 10 people each gave D 2 points, so 10 times 2, that's 20 points. And the next column, 8 times 2 is 16, 4 times 2 is 8, and 1 times 2 is 2 points. Okay, next row up. I'll move a little bit quicker now. 3 points for each of these 2nd choice votes. So here we got 14 people giving 3 points each. 14 times 3 is the calculation. That's 42. So everything times 3 in this row. 10 times 3 is 30. 8 times 3 is 24. 4 times 3 is 12. 1 times 3 is 3. And then finally, the top row, 4 points for every first place vote. And so here we got 14 people, each giving A 4 points. So we do 14 times 4. That is 56. 10 times 4 is 40. 8 times 4 is 32. 4 times 4 is 16. 1 times 4 is 4. Okay, and so now we got to push all these numbers together and give each candidate their total number of points. So starting with A, let's find all of the places where A got some points. So we've got A right there and right there, 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 and there. And in fact, you're going to find A once in every single column because every voter put A somewhere on their ballot. So let's just add up the points that A gets to get A's total. So 56 points plus 10 plus 8 plus 4 plus 1. So I think that's 79. Okay, next idea is to grab B. So again, looking for B in every single column. B will appear once, and then we just have to tally up all of these points for B. So what do we see here? 42 plus 30 plus 16 plus 16 plus 2. We get the total there, and we'll move on to C here. So C in every column, and then we add up those points. 28 plus 40 plus 24 plus 8 plus 4. And then finally D, I don't have any more highlighters, but D is the only one that's not highlighted, so easy enough to find. 14, 20, 32, 12, and 3. So it's just a matter of tallying all of these up. Okay, so I did the calculations. I got 106 for B, 104 for C, and 81 for D. So the winner of the Borda count method clearly should be the one that gets the most points. So in this case, that is B. So B wins this with 106 points. Okay, part B here. Here's a little check you can do to make sure you didn't make an error using Borda. Okay, so let's take a look at how many people we had voting. So remember, you can calculate that by doing a sum right here. So we're adding up 14 plus 10 plus 8 plus 4 plus 1. So let's see, 24, 32, 36. I think that's 37 people. And each person ranked somebody first and second and third and fourth. One single person ranked somebody first, second, third, and fourth. And so that means that one single person, one single voter, gave somebody, some candidate 4 points and gave another candidate 3 points and another candidate 2 points and another candidate 1 point. So if I add up here, 4 plus 3 plus 2 plus 1, we get 10 points, which means that each voter gives out 10 points. One single ballot. If I rank A and then B and then C and then D, I have given out 10 points to those candidates altogether. So if we've got 37 voters, each giving 10 points, and we want to know how many points there should be altogether, well, I think we need to multiply here. So in this case, we got 370 total points. So that 370, we should be able to check to see if we made any mistakes here, because we should give out 370 points looking at the sum of these four total number of Borda points. So we'll just add up real quick. We got 79 for A, and then 106, and then 104, and then 81, and then we cross our fingers and really hope that we get 370. So getting 370, I guess it doesn't technically mean we did it right. It is strong evidence that we did it right. It's possible we made maybe 2 different mistakes and lucked out and happened to get the right number, 370, but didn't do everything right in the middle. But that's not very likely. And for sure, if we got anything other than 370 when we did this calculation, it means we made a mistake and we need to go back up and try to find it. So we'll just say that when we add it up here, 79 plus 106 plus 104 plus 81, we got 370, which makes us happy. Part C, let's list the complete ranking of the candidates according to the Borda method. Okay, so we've already decided that B is the winner. So B was in first place with 106, and now we're looking for the second place person, which will have the second most number of points, 104 points, that's C. Next up, 81 points for D, and then finally 79 points for A. Okay, so then just listing it all together, B and then C and then D and then A in last place. Okay, and just one other observation here. So that's the Borda method, but we did talk about the plurality method on the previous page. And suppose that we just asked who would be the winner using the plurality method here. I'm just going to insert this, plurality. So plurality, remember, means only first place votes. So if we look at how many first place votes A got, so in this first column here, A got 14 first place votes, and I don't see any other A's in that first row. And so A has 14 total. B, looking for B's in the first row. So B in the first row I only see here, so that's 4 people. So B gets only 4 first place votes. C, I see a C there and a C there, so that's 10 people plus one more person. That's 11 people who thought that C was the best. And then finally D only appears in this one column in the first row, so that's 8 people. 8 votes for D. So the winner of the plurality method with the most number of first place votes is A. It was a pretty convincing win, right? 14 to 11. It's not that close. But then if we compare the winner A with the plurality method to how A fared using the Borda method, well, not only did A not win using the Borda method, but we saw down here in orange that A was actually dead last in the Borda method. And the reason kind of becomes clear if we look at how A did. We highlighted A in sort of blue highlighter. And so, yeah, there were 14 people who thought A was the best, but everybody else in this election, every other voter thought that A was absolutely the worst. They were quite objectionable, this A person here. And so it's a little bit disturbing maybe that the winner of the plurality method ended up not only not being the winner using this other way to count the votes, the same exact votes, the same exact preferences from the electorate, but that winner from the plurality method was actually dead last, according to another vote counting method.